Now we're going to work with the inverse function of linear and discrete functions. The first function we have is a discrete function, so we have to remember how that works. A discrete function sends the values of x into y as in any other function. So g function sends -2 into 8, 6 into -6, 7 into -3, and 8 into -2. That means that the inverse function is going to do the exact opposite. The inverse function has to undo what the original did. That means that the inverse function sends -2 into 8, -3 into 7, -6 into 6, and 8 into -2. So then, if I want to evaluate the inverse function in 8, that means I have to see to what value of x does the inverse function g sends the value 8. So as we can see here, the 8 value is sent to -2 by the inverse function. Now, the other set of exercises or questions are related to the linear function. The first one is asking us to find the inverse function. So remember, to find the inverse function, first we write this as a cardinal notation. Then we switch the places of the variables. And then we solve for y. In this case, we add 2 on both sides of the equation, and then we divide everything over 3. So this is my inverse function that I can write over here. Lastly, to solve the third exercise, this is asking us to find the composition of h with its inverse and evaluate that composition in -5. This can be easily done by just remembering one thing. If we have h and a function, if we have h and another function, h inverse, these functions are inverses. If this composition equals x, or if this composition equals x. This means that when we compose a function with its inverse, and I want to evaluate in something, I'm going to get in return that exact same value. Why? Because inverses cancel each other. So whatever I plug into this composition, because the operations of the original and the inverse cancel each other, whatever I plugged into it, it's what I get in return. So if I compose this function and its inverse and I plug a -5 into it, what am I going to get in return? The exact same value.